Welcome in this special session, a special topic. And in this session we will be dealing with something very elementary and very fundamental at the same time in software. That's the introduction of variability and its relationship with source code generation. My name is Herwig Mannaert. Now, suppose that we want to add two numbers, which is something extremely elementary. And so in this example, we have the numbers 8 and 15, and it's easy to add them ourselves, but you could imagine larger numbers that it would not be that easy. Now, we can, of course, write a program to add these numbers, and we can, of course, also run this program and say, look, Java, we run it, the program add 8 to 15, and it will give us the sum. Of course, this is a simple sum, we could do it ourselves, but there's another issue that if we want to do another sum, another computation, we have to change the program, recompile it, etc. So this is not very interesting. What we would like to do, for instance, is to add two arbitrary numbers, just pass them on. So we can write a program add where we pass through the command line two numbers and we add those numbers and we make the sum, which is of course a bit more nice. So if we do this, we can say add and we pass 8 and 15 and it will give us 23, but we can now just as well pass 54 and 23 and it will also make the sum. So that's already a bit more interesting. Now, of course, we can only do additions or take a sum. We could make it a bit still more interesting and say we have some basic calculators and we give three arguments. We give the argument the first number, we give the second number, and we also give the operation. And based on the type of operation, plus, minus, times or divided by, we do another computation, another calculation. So in this case, we go here and we can now not only say, for instance, calculator (8 and 15) plus, it will say 23, but we could also say 8 and 15 minus, or we could say 55, 23 minus, or we could even say 56, 7 and divided by, and it would give us the quotient. So this is already very much more interesting because now we can do all kinds of things. Now, first of all, an interesting remark is in software it's never that easy to say, do we have to do it all here, or could we just pass the computation on? So we could have more evolved computations instead of just a sum, a difference, a product, or a quotient. And if you would have more evolved computations, we could maybe pass it on. For instance, say, well, if it's a sum, we pass it on to an adder class. And if it's a minus, in this case not, but we could pass it on to another class, compute. So we have another class where we just can invoke the method compute. That's another example, another thing we can use, something interesting as well. So it's not that clear whether we should do everything here or pass this on. For instance, we can use this computer in the same way and it will work just as well. Okay. Another thing is that maybe we would like not always to start the program, to invoke the program, to do a calculation, but just stay in the program and have the program doing the calculations we want. for instance, we could say we have a loop, we stay in the loop, we read what is being typed on the command line, and we say we perform the computation. But in this case, it would be more pleasant to be able to type the operation between the two numbers or arguments. So we take the first and the third argument as the numbers, and we take the second argument as the operation. And then it becomes a little bit more interesting because we kind of stay in the program and we say, look, we have a calclab, which is kind of a very embryonic, kind of nano MATLAB, but it's kind of an embryonic tool to make computations. And we say, okay, 8 plus 15, and it's 23, and we say 7 times 8, and it's 56, and we say 28 divided by 4, and I forgot the space, it's not very robust, of course. 28 divided by 4, and it's 7. So, and we can do all kinds of computations, 54 plus, and it will do it. And if we quit, we go on, we say, well, if we don't type anything, we go out of the loop and we go on. You see that it's not extremely robust, very simple program, but nevertheless, we have a kind of computation environment, some kind of embryonic mini MATLAB. And so we create variability. We started from adding two specific numbers to adding arbitrary numbers to performing a kind of operation we can specify on numbers in various ways, and we can also do that in a kind of command shell where you have some kind of a computing tool. But however, we could also, if we say, for instance, like here, we do something in a separate class. We have separate classes for a specific operation or for an operator, because here a plus, a minus, a times, and a divided by is simple, but we could have powers, logarithmics, sinuses, complex things, so we could have more classes. Well, if we have more classes, we would have to code a lot. And so there is another way of achieving variability. And this other way of achieving variability, that is basically that we could say, well, we generate code, but because all this code is quite similar. And we go here and we look, for instance, at a class being able to perform an addition. And we say we have a class adder, we have a main method, but we also provide a method for other classes to invoke the addition. So you can have a main method from the command line, or you can invoke the addition. Now, this doesn't look too much specific code for the fact that we are performing an addition. Actually, the only thing specific is that it is called adder, yes? And the other specific thing is the actual operator, which we find here. So we could imagine a kind of a template for all these kinds of classes and would say, look, all these adder, multiplier, subtractor, divider, they would look something like this, where we would have a name, and then the only thing that would be different would be this symbol for the operator. So, and instead of coding this all the time, we would have another kind of variability through code generation. We said, well, if we just provide the name of the operation and the symbol of the operation, we can generate the code for this adder. Therefore, we need, of course, a generator program. And the only thing we actually still need for this generator program is to read the template, to write the code, and actually to insert or replace the actual values of the operation and the symbol. So for that purpose, because there exists all kind of solutions. It's very interesting to use our own very simple solutions. We have a simple class reading a file, turning it into a string, a simple class writing a string into a file, and a very simple class performing a replacement where you replace one string with another and injecting something. Much more in a string, much more we don't need. So we don't need a fancy library or a tool or a templating engine. We need something to read a file, to write a file, and to replace and or insert something in a string. So if we have that, then you can see basically that you say, well, I want to read the template by the resources because there is my template. I want to be able to write the code in the generator code. I have a string handler. So I read this operator template, which looks like this, with a name and a symbol. And when I read this operator template, I use this string handler to replace the name between percentage signs by the first argument, to replace the symbol by the second argument, and actually to write the code in a file with the name of the operation. So how could we invoke this in a very simple way? We would just have a generate operator where we just specify the name and the symbol. So we would say generate operator, header, and the symbol. And it would just generate this file. And if we now look at it, we see that in the generated directory, we now have this header, which looks the same, but we can now also generate, for instance, the subtractor. And now, well, I did the same thing, so, which was not good. I have to do an header with plus and a subtractor with minus. And now we have two classes. But of course, the whole point of programming is to consolidate knowledge, to consolidate what you do. You program to consolidate what you normally do, or you do source code generation to consolidate your programming. So what we actually need is some way to remember what we have to type. And so we make a script to automate that. And we could see, look, we generate an adder, that's a symbol, a subtractor, a multiplier, and a divider. And to make sure that they are correctly generated, we go into the directory with the generated code, we compile it, so we check it compiles, and we even perform a simple addition and a simple multiplication to be sure. Now, if we run this script now, which is called test operators, everything is run. We see that the adder performs the way it should be, the multiplier performs the way it should be, and we also see that if we go into the directory of the generated classes, we now have 4 generated classes and they are all compiled. So we don't only have a piece of source code generation, we also have some kind of a script consolidating the knowledge, testing it, compiling it, and when we would change the template, would change the source code generator or change the template, then we could just run the script again and everything would be generated, compiled, and tested again. So we started from performing a simple addition to adding two arbitrary numbers, to parameterizing the operation, then to have some kind of a embryonic nano MATLAB command environment, and then introduce another way of introducing this variability, code generation. Now this code generation is also interesting if we look, for instance, at what we have learned in programming classes to represent nouns, to represent basically data objects or data transfer objects. So if we go there and we take, for instance, a class person, and person has a number of attributes, a name, an age, a position, and they have a default constructor and some getter and setter methods. Now basically we could use exactly the same scheme and the same structure to make a data transfer object, to make a class to represent any kind of noun, any kind of thing. We could also do this for a cat, a rocket, whatever, a bicycle. Because it's always the same. Now what we see is a kind of a skeleton, and then we have some attribute definitions and some get and set methods. So we could once again make a template, and the template we would have to introduce a bit of hierarchy. We would have a main skeleton template where we say, well, the name of the noun would be filled in here, also in the constructor, but that template just has a position for the attribute definitions, the get set methods, but doesn't actually contain them. Because if it would contain them, we don't know how many attributes you have. So we have other attributes, a simple template to define an attribute with a type and a name. And we have a simple template to create a get and a set method, where you have the type of the attribute and the name of the attribute. Okay, so these are templates, and with these templates we should be able to generate person, but not only person, basically every kind of data object. So we go here and we look into the noun generator. And what we need first of all is what we just made for the generation of the operations. Some readers to read some files. We would have models, descriptors to define the nouns, the attributes, something to read the templates, something to write intermediate results so we can look at them whether nothing went wrong, and something to handle the strings. And so what we would do first is we have a certain noun, for instance person, and the first thing that we would do is to read the descriptor. So we take this constructor, and the first thing we do, we read the descriptor. And how does such a descriptor would look like? Well, we would just enumerate the various attributes with their type and their name. So you have a string representing the name, an int representing the age, and a string representing the position. And then we would have a small Java program that reads these couples, these pairs of type and names of attributes, and stores them into array lists. So it would just go through all the lines of this small descriptor file, and it would just store the types in an attribute type array list, and it would store the names in an attribute name array list. And they would be available through this noun descriptor. So that's the first thing we would do. We would just basically read this descriptor. Now, the second thing we would do is, of course, to generate the skeleton. So remember, in the skeleton, we only fill in the skeleton, we replace name by person, and we fill in the skeleton. So if we run this program, for instance, for a certain kind of noun or data object, We just run this program and we say, look, run noun generator for a person. And so we read the descriptor, and now we can take a look at the intermediate files, because we see in the noun generator that the skeleton will take the template for the skeleton, that it will replace the name of the noun by the name of the noun, and it will result in a skeleton. So if we take a look at it, we see, for instance, in the temp directory that we have now something very recently being a person skeleton. I'm gonna remove the other ones so we have a clearer view. So we have here we remove everything and we run it again. Yes, and we see that we now have the intermediate files for the person, and so we have the person skeleton. We go back to the noun generator and we see that in the next phase, after the skeleton is being generated, we add the attribute definitions. And how do we add the attribute definitions? Well, that's very simple. We loop through the array list of attribute types and names, and we take the attribute definition template and we replace every time for every attribute the type by the actual type, the name by the actual name, and then we insert or inject all these attribute definitions before this anchor, before the end of the attribute definitions. Okay, so that has been done as well, and we store then this intermediate result, and if we look there at this intermediate result with the attribute definitions, then we see that we have for this person not only the skeleton of the class, but we also have the various attribute definitions. And then we go to the next phase, adding the get and set methods, and adding the get and set methods happens in exactly the same way. We loop through the array list of the attribute types and attribute names. We loop through the array list. We take the attribute get and set template, and every place where we see type between percentage signs, we replace it by the actual type. Every time we see name between percentage signs, we replace it by the actual name. We create a get and set method for every attribute, and we inject or insert them before the end of the get and set methods in this anchor. And we write an intermediate file with all the get and set methods. And so if we look at this intermediate file, we see that then everything is there. This is basically the person class. So basically we see that the code generation is done, and we see the only thing we still have to do is to write the file. This file is then actually written where the source code is written in this gen directory. So we go in this generated classes, we see a person list, for instance. Person and person list, and I will come back to that right away. Why do we also have a person list? Well, if we are generating code now, we can generate a person, but we can just as well generate a class to represent a person list. That's not much more difficult. So we can do that just the same. So why not do that as well? We could have just as well a person list, yes, and from this person list we could easily generalize this a bit, introduce some variability, and just replace person by noun between percentage point, making it into a parameter, making it variable, so we can replace it. And so by just taking this template as well, yes, we see that we here generate a noun list, and this is very simple. We take the noun list template, and everywhere we see noun between percentage point, we replace it by the actual noun. And based on that, we now also have a person list. So in the generated code, we have a person and now also a person list. Now we had it, of course, because we used these classes to create the templates. But the nice thing is that we can now do it not just for a person, but we can do it for any noun. For any noun, we can create a data transfer object or a basic class and a list class. So we can do that for any noun for which we have a basic descriptor. So if we go and look at the descriptors, we see that in the models, as we call them, we have a descriptor not only for a person, but also, for instance, for a cat, which has a name, an age, an address, a gender, and a color. And so if we would run this for a cat instead of a person, we would end up having the same kind of files. So now we see that what wasn't there before, we generated a cat and a cat list where we have the attributes, the getters and setters for the cat. And we also have a cat list. And we could do just the same for the rocket. For instance, we have a descriptor file for the rocket where we say, look, a rocket is characterized by a name, a producer, supplier of the rocket, the number of engines and the height of the rocket. And so if we then run our noun generator for the rocket, we can create both a class to represent the rocket, a DTO, and we can create another class to represent a list of rockets. And so we go here and we see we have a rocket with the various attributes of the rocket, with the various get and set methods, and we have, for instance, also a rocket list class, being able to store an array list of rockets, actual rocket types. Now, once again, of course, it's very important to be able to run it, but to consolidate the knowledge. We make code generation to consolidate the knowledge. And now we also have to consolidate what we did here. We invoked the code generation for a cat, for a rocket, for a person. So we want to consolidate that and we want to test that. So for instance, we have here a script consolidating what we have to do to perform this generation. So we can do it all over again when we, for instance, adapt or improve the templates for the data transfer objects or for the list objects. We can rerun it, and we run it to create classes for person, cat, rocket, bicycle. And to be sure that the thing works and that the code which is generated at least compiles correctly, we can go into the gen subdirectory, compile the code, and check whether it works. So I'm gonna clean up all the files because they're gonna be regenerated again. And so we go here and we say test the noun generator. and we see that they have been generated and compiled successfully. So the generated code was okay, and we see now that we have all these classes, the list classes. We have generated 8 classes which have all compiled correctly. So far for this, at the same time, extremely elementary topic, introducing basic variability and going through to code generation, because it's also kind of variability, but at the same time we have looked at some very, very basic couple of lines of software code, and we have generated and compiled 8 classes to represent data objects and list classes. If you have any questions, you can contact me.